In this video we are going to discuss the solutions of the unit test 4, right? The test consists 45 questions, and this video we are going to discuss 15 questions. Okay? जिनके पास भी पीडीएफ नहीं है तो डिस्क्रिप्शन में पीडीएफ का लिंक दिया है, वहाँ से पीडीएफ डाउनलोड कर लो, बिकॉज हम क्वेश्चन पीडीएफ वाले क्वेश्चन के सीक्वेंस में करेंगे, राइट? सो ज़्यादा टाइम नहीं लेता, फटाफट क्वेश्चन लोड करते हैं एंड देन सॉल्व करना शुरू करते हैं. Okay. The question number 1. A mass m is moving with constant velocity parallel to x-axis its angular momentum with respect to origin. Right? How it is? ये x-axis हो गया एंड ये origin हो गया. ये origin हो गया. And the object is moving along this line. So, what is angular momentum? Angular momentum होता है m into v into perpendicular distance from the reference point. That is called the angular momentum. Because the point origin itself is on the axis, so perpendicular distance is 0, so angular momentum will be 0. Right? So there will be no angular momentum in this case. The ratio of moment of inertia of a ring about an axis passes through its rim and perpendicular to its plane. Right? ये हमारा एक ring है, ये perpendicular to plane and passing through rim, and that about diameter, and this is about diameter. Right? तो ये सपोज I1 है और ये सपोज I2 है. So moment of inertia of ring about an axis passing through rim is how much? That is 2mr square, right? And moment of inertia about the diameter is mr square by 2. So this ratio comes out as 4. So that is 4:1. सिंपल क्वेश्चन था, ये फॉर्मूले तो मोमेंट ऑफ इनर्शिया को आपको याद करने पड़ेंगे, उससे ही होगा. दैट इज अ यूनिफॉर्म सर्कुलर डिस्क ऑफ मास m रेडियस r is rotating angular velocity another disk of mass. Right, this is the question of conservation of angular momentum. What is happening there? A disk is rotating, the radius of the disk is r, the mass is m, and the disk is rotating with angular speed omega. So it will have definitely some angular momentum. What is the angular momentum? That is moment of inertia. How much is it? mr square by 2 into angular speed omega. Now what we did, we placed another disk over it. When we place another disk over it, then what will happen? The overall moment of inertia will increase, so angular velocity will decrease. So let's place another disk over it. That is, the size of disk is same, but the mass is m by 4. So what will be the final angular momentum? The moment of inertia of the both disk, that is into the new angular speed. Let's say the new angular speed is omega dash. Then by the conservation of angular momentum, because we have not applied any torque in this system, हमने कहीं पे भी टॉर्क अप्लाई नहीं किया, तो कंजर्वेशन ऑफ एंगुलर मोमेंटम लगाएं. सो देन इनिशियल एंगुलर मोमेंटम शुड बी इक्वल टू फाइनल एंगुलर मोमेंटम, दैट इज mr square by 2 into omega is equal to this. You will calculate, so then with this will come 5 by 4 mr square by 2 omega dash. Here the 2 will be there, right? So now this mr square by 2 is cancelled, so omega dash is 4 by 5 omega. So that was a simple question of conservation of angular momentum, right? Let's move to the next question. A spherical ball rolls on a table without slipping, then the fraction of its total kinetic energy associated with rotation. what we need to find out the ratio of kinetic energy associated with rotation to total kinetic energy, right? The energy associated with rotation is half I omega square, while total energy in rolling motion consists two different motion, एक translatory motion और एक rotational motion. So that will be the sum of both the energy. Both the energy will be half mv square plus half I omega square. Now let's see this. This is equal to half. This is a ball. The moment of inertia of ball is 2 by 5 m r square. In the pure rolling, omega is equal to v by r upon half mv square plus half into 2 by 5 mr square into v square by r square, right? This r square cancel, this r square cancel, then mv square cancel. So what is left? On the top it is left 1 by 5 and on the bottom it is left 1 by 2 plus 1 by 5. So how much is 1 by 2 plus 1 by 5? That is 5 to 7, 10. So this is 1 by 5 into 10 by 7. That is 2 by 7. Right. So the answer is 2 by 7. The one important thing in this, right? Whenever you have the moment of inertia of any body, you will have a numerical factor associated with that moment of inertia. Like in this case, the numerical factor is 2 by 5. Because moment of inertia of ball होता है 2 by 5 mr square. So this is numerical factor. Forget this part. Now this 2 part is rotational energy and 7, this 5 part is translational energy. So total energy is 5 plus 2, 7. So energy associated with rotation is 2 by 7, while energy associated with translatory motion is 5 by 7. This is a quick method to find out the energy associated with a particular part. Right? Hope so you understood. The next, a rod of length hinge at the bottom is held vertically and then allowed to fall. The linear velocity of its top when it hits the bottom. So what we did, this is a rod and we allow it to fall, so then it will fall and finally it will stand like this. We have to find the velocity of this part. The length of rod is L, right? So that is a simple question of energy conservation. The potential energy of the rod will convert into kinetic energy. So the potential energy equals kinetic energy. Now how much is the potential energy? The length of rod is L. So you will say mgl. No, it will not be mgl because the rod length is L. The mass is distributed from bottom to top. पूरा mass distributed है, तो हम क्या करेंगे, इसका center of mass लेंगे, क्योंकि weight कहाँ पे होता है, center of mass पे, और center of mass की height कितनी है, L by 2. So the weight is at height L by 2. So the potential energy of the system will be mg L by 2. Now the kinetic energy. This is rotating about this end. The rod is rotating about this end. So this is a pure rotation, rotational in motion. So the kinetic energy will be half I omega square. That is mg L by 2 is equal to half I. The moment of inertia of the rod about an end. This is rotating about an end. एक end के about rotate कर रही है. So the moment of inertia of a rod rotating about an end is ml square by 3 and omega is v by L square, right? So this 2, 2 cancel, m cancel, this L square is cancel. So we get V square is equal to 3GL. So the V is root 3GL. So that will be the right answer. Right? The question number 6. A solid cylinder of mass m and radius r rolled down an inclined plane from height h without slipping. The speed of its center of mass when it reaches the ground. What is happening? A cylinder hai, it is rolling down and it reached the ground. Let's say the speed is v when it reached the ground. But it is rolling down. क्योंकि ये roll कर रहा है तो सिर्फ linear velocity ही नहीं है, angular velocity भी होगी, omega. And because it started rolling down from the height h, so this potential energy of the cylinder will convert into the kinetic energy. So conservation of energy लगाएंगे, potential energy is equal to kinetic energy. How much the potential energy was? The potential energy was mgh and the kinetic energy of rolling motion. दोनों energies होती है, rotation वाली भी और translational वाली भी. तो translational motion वाली mv square and rotational वाली half I omega square. Right? So now it is a solid cylinder. So what is the moment of inertia of solid cylinder? That is mr square by 2, and omega we know in the rolling motion, that is v by r. So this r cancel, so we will have 3 by 4 mv square and that is mgh, mm cancel हो गया, तो v is equal to root 4gh by 3. So the correct answer is root 4gh by 3. Okay, hope so आपको समझ में आ रहा होगा. अगर कहीं पे भी कोई प्रॉब्लम है समझ में आने में, then write to me on the comment box. I will correct that. Two bodies with moment of inertia have equal angular momentum if E1 and E2 are their rotational energy. Then, right, what we have, I1 is I1 greater than I2. I1 greater than I2. And what we have, L1 is equal to L2. The angular momentum is equal. We have to find the relation among the energy. तो पहले तो एनर्जी का रिलेशन होता है एंगुलर मोमेंटम के टर्म्स में. देखो एनर्जी होता है हाफ आई ओमेगा स्क्वायर. अगर मैं इसको आई से मल्टीप्लाई डिवाइड कर दूं तो दिस विल कम एज एल स्क्वायर बाई 2i. राइट नाउ बिकॉज एंगुलर मोमेंटम इज सेम, सो E is proportional to 1 by I. So what I will say, E1 by E2 is equal to I2 by I1. So I2 by I2 is lesser, I1 is greater, so E1 is lesser than E2. ओके, यहीं से पता चलता है मोमेंट ऑफ इनर्शिया कम होगा तो एनर्जी ज़्यादा होगी, मोमेंट ऑफ इनर्शिया ज़्यादा होगा तो एनर्जी कम होगी. राइट, सो देन E1 लेस देन E2, दैट इज द राइट आंसर. नेक्स्ट इज arrange a disk and a solid sphere all having the same mass and radius rolling down an inclined plane from the same height. कुछ ऑब्जेक्ट है जो सेम हाइट से रोल कर रहे हैं. Which will reach the bottom first? देखो, in the rolling on inclined plane the acceleration होता है 1 plus 1 by g sin theta upon 1 plus I by mr square. This is what is the acceleration of an object rolling down an inclined plane. 1 plus I by mr square. Right? तो हम क्या करेंगे? देखो, अब एक्सेलरेशन कम तो फास्टर होगा, तो विच विल रीच बॉटम फर्स्ट, जिसका एक्सेलरेशन सबसे ज़्यादा होगा वो सबसे पहले पहुंचेगा. तो सबसे ज़्यादा किसका होगा? जिसका ये सबसे कम होगा. ठीक है, I बाई एम आर स्क्वायर जिसका सबसे कम होगा. I बाई एम आर स्क्वायर अगर हम निकालें for the ring, that is 1. What we are calculating? I by mr square. For the ring it is 1, for the disc it is half, and for the solid sphere it is 2 by 5. So this comes out as 0.4, this comes out as 0.5, and this is 1. So the least I by mr square किसका है? Solid sphere का. So who will be the winner? Basically एक रेस हो रही है, तो कौन विनर होगा? ये हो जाएगा, राइट? तो भैया ऐसा कुछ मुश्किल नहीं है, आराम से करते जाओ, होता जाएगा. The next question. A wheel of mass 40 kg and radius of gyration is 0.5. The radius of gyration is 0.5. The mass is 40. Come to rest. Yani final speed is 0 from a speed of 1800 revolution per minute. Yani jo initial frequency thi, that was 1800 RPM. Right? So in 30 seconds, and this all is happening in 30 seconds. Assuming that the retardation is uniform, the value of retarding torque. So F naught, इसको RPS में convert करो, तो 1800 by 60 is equal to 30, right? So omega naught, the initial velocity, that is 2 pi F naught, that is 60 pi. This is 30, so 30 into 2 pi is 60. Now go by omega is equal to omega naught plus alpha t. Final is 0, initial is 60 pi, alpha हमें मालूम नहीं, t is 30. So alpha is 2 pi and this is minus. So torque is equal to I alpha. Now what is moment of inertia? The moment of inertia is I is equal to mk square. In terms of radius of gyration, this is 40 into 0.5 square. So that is 10, right? So then we have torque is equal to 10 into minus 2 pi, that is minus 20 pi. The minus sign is representing the retarding torque. This is the retardation, so this is will be retarding torque. ये retarding torque है, तो इसलिए माइनस साइन आ गया. क्या परेशान होने की जरूरत है? माइनस हो गया तो हटा दो, 20 लिख दो, बिकॉज साइन तो रिटार्डेशन के लिए है. Two men A and B are carrying a uniform bar of length L on their shoulder. The bar is held horizontally such that A gets 1/4 of load. If A is at one end of bar, the distance of that end is, right? This is what एक rod है, and at this hand we have A, and somewhere here is B. Then A get 1/4 of the load. So what the B will get? 3/4. If 1/4 is with A, so what will be with B? That is 3/4. जितना बचेगा. And the net weight is at center. The weight is at center. This distance is L by 2, and let's assume this distance is x. Now the rod will be in equilibrium if the moment of force, yet torque on the rod become 0. So torque by A should be equal to torque by B. The torque is force into perpendicular distance. Now E will apply a force of W by 4 and B will apply a force of 3W by 4. So A will tend to rotate in this direction and B will tend to rotate in this direction, because both torques are opposite, right? Both torque are opposite, so the net torque will be 0 when they are equal. So the torque of A is W by 4 into L by 2, and torque of B is 3W by 4 into X. W/4 तो x is equal to L/6. So that is L/6 from this end, from this B. हमको फाइंड आउट करना है कौन सा डिस्टेंस, हमको फाइंड आउट करना है ये वाला डिस्टेंस. तो ये डिस्टेंस कितना हुआ, दिस मान लो y मान लो. सो दिस y इज इक्वल टू L/2 प्लस L/6. L/2 plus L/6, so 2 3 just 6, 3 and 4, so this will be 2L/3. So from that end distance is 2L/3, right? So this was the question of equilibrium. Yani in the system is in equilibrium, right? Next, a flywheel is in the form of circular disc of radius 1 meter and mass 2 kg. Radius 1 meter and mass is 2 kg. The work which must be done on it to increase its frequency of rotation, yani F1 is equal to 5 to F2 is equal to 10, right? So what do we do? The work done is equal to change in energy. So work done is equal to change in energy, that is half I omega 2 square minus omega 1 square. तो हमको ये पैरामीटर्स चाहिए I, omega 1, omega 2. तो पहले तो I निकाल लो. Because it is like a disk, so that will be mass into radius square by 2, that is 1. Then omega is equal to 2 pi 5, that is 10 pi, right? And omega 2 is 2 pi into 10, that is 20 pi, right? So this will become half. I is 1. इसमें दोनों में पाई है तो पाई स्क्वायर बाहर ले लो. Then 20 स्क्वायर माइनस 10 स्क्वायर. नाउ पाई स्क्वायर की वैल्यू लगभग 10 होती है. पाई स्क्वायर की वैल्यू लगभग g के बराबर होती है. यू कैन टेक फॉर 10 approximately because we have to find the approximately. Then 20 square 400 minus 100, that is 300. So that is 1500 joule. 1500 joule will become 1.5 into 10 to the power 3 joule, right? So work energy theorem rotational motion में भी लगती है. वर्क एनर्जी थ्योरम सिर्फ मोशन ट्रांसलेटरी मोशन में ही नहीं होती. A solid cylinder of mass 50 kg and radius 0.5 meter is free to rotate about its axis, which is horizontal. A string is wound around the cylinder. So this is a cylinder and a string is wound around this and one end attached to it and hanging freely. The tension is required to produce an axle. यहाँ पर हमको एक टेंशन देनी है जिससे इसका एंगुलर एक्सेलरेशन 2 रिवॉल्यूशन पर सेकेंड स्क्वायर हो जाए, राइट? सो दिस इज एक्सेलरेशन इन रिवॉल्यूशन पर सेकेंड स्क्वायर. तो हम इसको कन्वर्ट कर लेते हैं एंगुलर एक्सेलरेशन में. दैट इज 2 पाई इंटू 2, दैट इज 4 पाई. सो द एंगुलर एक्सेलरेशन विल बी 4 पाई. तो यहाँ पे ये वर्ड लिखना ठीक नहीं रहेगा बिकॉज वी आर यूजिंग अल्फा हेयर. सो वी आर गिविंग इट अ एक्सेलरेशन ऑफ 2 रिवॉल्यूशन पर सेकेंड स्क्वायर. व्हाट डज द रिवॉल्यूशन पर सेकेंड स्क्वायर मीन्स? इतने रिवॉल्यूशन पर सेकेंड एक सेकेंड बाद इंक्रीज हो जाएंगे, यानी 2 रिवॉल्यूशन पर सेकेंड एक सेकेंड में 2 रिवॉल्यूशन बढ़ जाएंगे. तो हमारा एंगुलर एक्सेलरेशन आया 4 पाई एंड हमको चाहिए टेंशन. तो टेंशन विल कॉज द टॉर्क. तो टॉर्क इज इक्वल टू होता है आई अल्फा. तो टेंशन विल कॉज द टॉर्क. तो टॉर्क इज टी इंटू आर एंड मोमेंट ऑफ इनर्शिया बिकॉज इट इज ए सॉलिड सिलेंडर. तो दैट विल बी एम r square by 2 and alpha is 4 pi, right? So that will come out as 25 pi square. 25 or ये, right? So this will be t into 0.5, that is 25 into 400 pi into 0.5 square, ये square cancel हो गया इससे, so that will come as 50 pi. 50 pi हो गया करीब 157 Newton. So the answer will be 157 Newton, right? Next, A and B are two solid spheres of equal masses. A rolls down an inclined plane without slipping from a height of 3 meters. B falls vertically from the same height then on reaching the ground. What is happening? A ऐसे घूमते घूमते आ रहा है और B ऐसे फॉल कर गया, राइट? सो दोनों में एनर्जी इक्वल था और नीचे जाके भी एनर्जी इक्वल ही रहेगा, क्योंकि कंजर्वेशन ऑफ एनर्जी तो अप्लाई होगा ही होगा, मैकेनिकल एनर्जी कंजर्वेशन. हाँ, इसमें जो एनर्जी है वो पार्ट ट्रांसलेशनल मोशन में जाएगा और पार्ट रोटेशनल मोशन में जाएगा, लेकिन इसमें सिर्फ ट्रांसलेशनल मोशन होगा, तो इसलिए स्पीड तो दोनों की सेम नहीं होगी, राइट? बट एनर्जी दोनों की सेम होगी, तो बोथ कैन डू इक्वल वर्क्स, तो दोनों इक्वल वर्क कर सकते हैं, राइट? Question number 14. A circular plate of uniform thickness has a diameter of 56 centimeter. A circular portion of diameter 42 centimeter is removed from 1 inch the distance of. Okay. This is one of the disc, out of which we removed this part. ये पार्ट हमने रिमूव कर दिया. अगर मैं इसको देखूं तो ये इसकी लाइन सेंटर से पास हो रही है, ओके? देन दिस विल बी द सेंटर ऑफ, एक मिनट, ये हो गया पूरे उसका सेंटर और ये हो गया इतने पार्ट का सेंटर, राइट? Now what we have, what we are given, this is 21 and this is 28, right? The diameter of that is 56, so radius हो गया 28 and this radius is 21. Now this is the center of big disc, this is the center of small disc. And let's say this is somewhere the center of disc. O2 मान लेते हैं इसको और इसको मान लेते हैं O1. तो अगर मैं इनको स्ट्रेट लाइन के फॉर्म में देखूं, स्ट्रेट लाइन के फॉर्म में देखूं, so this is what is the center O, this is what is center O1, and here is somewhere center O2. Now this distance is, this 28 minus 21 is 7 and ये distance हमें calculate करना है x, ये distance हमें calculate करना है. तो अब ये 3 सेंटर हैं. अब देखो पूरी डिस्क का mass of big disk, I'm using the same color for the disk, mass of big disk, that is डेंसिटी इनटू एरिया. एरिया कितना हो गया? पाई आर स्क्वायर 28 स्क्वायर, राइट? दैट इज द मास ऑफ बिग डिस्क. एंड मास ऑफ स्मॉल डिस्क, मास ऑफ स्मॉल डिस्क दैट इज डेंसिटी इनटू पाई इनटू 21 स्क्वायर. एंड मास ऑफ द रिमेनिंग पार्ट, यानी इसका मास ये मैं ले रहा हूँ m1, तो इसका मास हो गया m2 इज इक्वल टू m माइनस m1, ये आ गया m माइनस m1, राइट। सो इसका मास कितना है m1, इसका मास कितना है m, और इसका कितना है m माइनस m1, राइट। अब आपको सेंटर ऑफ मास की पोजीशन फाइंड आउट करनी है। देखो जो छोटी डिस्क है, ये वाली डिस्क, जो छोटी डिस्क है जो हमने काट दी, और जो सेक्शन है यानी m1 और m2, m1 और m2 का सेंटर ये है O, m1 और m2 का सेंटर O है, और हमको मालूम है अगर मैं इसको ओरिजिन लूं, if I take this origin, so we have the formula for center of mass as x is equal to m1 x1 plus m2 x2 upon m1 plus m2, right? So x is equal to m1 is m1, x1 is यहाँ से यहाँ तक का distance, that is x1, right? This is 7 plus x plus m2, m2 is m minus m1, and this is at origin, so this x2 is origin upon m1 plus m2 is m. So what we get is m into x is equal to m1 into 7 plus x, right? अब m कितना है, that is density into pi into 28 square into x. m1 कितना है, density into pi into 21 square and then 7 plus x, right? Density into pi तो cancel हो गया. Now I can divide by 7, so 3 and then 4. So this will come as 7 3 is 21, 7 4 is 21. So this will come as 16x is equal to 4 का square 16, x is equal to 9 into 7 plus x, right? 9 into 7 plus x. So that is 16x is equal to 9 7 is 63 plus 9x. So that will come here. So that is 7x is equal to 63. So x is equal to 9. X is equal to 9. Means this distance is 9. So from the center of the plate, yani from here, this distance comes out as 9 centimeter. ये distance आया हमारा 9 centimeter. So that will be the answer. Now, whenever you get a question of the section, तो आप एक चीज देखना, जो निकाल के फेंक दिया और जो बचा, उन दोनों का सेंटर जो ओरिजिनल था उसका सेंटर होगा. So that is the basic concept of solving these type of problem, right? And the last of this, a uniform rod PQ of length L. एक rod है, this is hinged at this point and it is connected with a string at this point. It is connected with a string at this point and it is like this. It will definitely have some weight, this weight, and the length is L. Now what we did, we cut the string. हमने string को काट दिया. String काटते ही ये rotate करेगी with an acceleration alpha. Then simple torque is equal to I alpha. I is moment of inertia of rod. The rod is rotating about this end. So about an end, the moment of inertia is ml square by 3. और अल्फा तो हमको निकालना ही है. Torque will be because of the weight. तो mg into this distance is L by 2. So that is mg into L by 2. So m cancel, एक L cancel, तो alpha is equal to 3g by 2L. 3g by 2L. So that will be the answer. So this is our first video, question number 1 to 15. आगे क्वेश्चन सेकेंड और थर्ड वीडियो में मिलेंगे. इस वीडियो के लिए इतना ही. थैंक यू एवरीबॉडी.